Once you have built and tested the AfroDuinoBOT Primo electronics and assembled the robot, you can add the line following sensor. Videos showing you how to build the electronics and assemble the robot chassis are available at youtube.com/electronicsafrica. There is also a complete electronic textbook available online at robotscience.co.za/datasheets. The datasheets show you how to program your robot once it's been built. You want to download the datasheets for the AfrikaBOT 3. Before you start making the line following sensor, you want to make sure that your robot is working properly. We recommend you download and work through datasheets 4.01 through 4.05 until you are confident that you can drive your robot around without any difficulty. If you are unsure of how to do so, you can find out more about how to connect the controller to the computer and how to download programs to your robot with datasheet 1.01 through datasheet 1.10. To assemble the line following sensor, the first thing you want to do is locate the small printed circuit board marked Phototransistors and its companion printed circuit board marked white LEDs. You want to break these boards away from the other printed circuit boards and remove the sharp pointed parts where they were joined to the other boards with a small file or a piece of sandpaper, taking care not to damage the printed circuit boards. Be careful with the dust. It contains tiny particles of glass fiber which should not be inhaled, so take a ball of press stick and use it to pick up the dust and clean the boards. Now you will want to locate the parts. Be careful not to mix up the white LEDs and the phototransistors, as they look very similar. The way to identify the phototransistors is if you look into them, you will see there's a tiny small square black piece of silicon. Inside the white LEDs, it looks like a milky yellow color. Starting with the light transmitter printed circuit board marked white LEDs, we locate the 220 ohm resistors that can be identified by their red, brown and gold stripes. You can do a Google search to find a nice resistor color code chart download. You can also download the AfroDroid app to your smartphone, which will help you decode resistor values. In the electronics kit for the AfroDuinoBOT Primo, there are several packs of parts. Be careful not to mix up the small resistors that are meant to go on the printed circuit board with the larger resistors that are meant to go on the breadboard. The smaller resistors are 1/8 watt resistors, and they are the correct size to go on the printed circuit board. The larger resistor, which you can see here in the video, is a 1/4 watt resistor, and it is intended for use on the breadboard and not on the printed circuit board. Here we are inserting the 220 ohm resistor on the board. The white silkscreen markings with the number 220 inside the circles show you exactly where to put them on the board. The resistors can go in any way around. In other words, they do not have a positive and a negative lead. With many other electronic parts, it is important they go in the right way round, but that's not the case with resistors. The larger resistor, as you can see here, is too big for the allocated space, and you won't be able to get it to lie down properly on the printed circuit board. So let's remove it and replace it with the correct part. Once you have the 220 ohm current limiting resistors on the board, it is time to solder them in place. Make sure you have an electronics grade soldering iron and a stand with a wet cellulose sponge. Please watch our YouTube video on high quality soldering for electronics if you've not done so already. Remember, it is absolutely important that the soldering iron is not too hot and not too cold. Also, you want to wipe the tip of the soldering iron on the edge of the sponge every time you pick the iron up. You should not apply the soldering iron to the printed circuit board unless the tip looks perfectly clean and silvery. You want to use no clean type solder, which is available from mantech.co.za. You do not want to use hardware grade solder that leaves a thick brown corrosive residue on the board. If you use that type of solder and do not clean the board with surgical spirits, Then, after a while, that acid residue will damage your electronics. Once you are done soldering, clip away the excess lead length with an electronics grade side clippers. Now you will see the white circular markings on the printed circuit board to guide you in the placement of the bright white LEDs. The markings on the printed circuit board showing where the parts go is called a silk screen because that is how it is printed onto the board. Notice how the circles are indicated with a dotted line. The dotted line is telling you that the part actually gets mounted on the other side of the printed circuit board and not on the silk screen side. The resistors are in fact mounted on the silk screen side. You will also notice there is a solid white line on the one side of the circle in the silk screen for the white LEDs. That is to help you get the part in the right way around. If you look at the LED, you will see there is a flat spot on the body of the part on the edge. If you match the flat spot on the edge of the body of the LED with the indicated flat spot on the printed circuit board, then the circuit will work. Check again you have the right part. The bright white LED is yellow inside. Then locate the flat spot on the body of the part correctly. Notice how the leg on the flat spot side is shorter than the leg on the other side. The leg on the flat spot on the side of the LED connects to the cathode. That is the leg that should go through the hole on the printed circuit board closest to the flat marking. The cathode leg of the LED should be connected towards negative. You will notice the other leg is longer. That is the anode of the LED and should be connected towards positive. The tracks act like wires joining up the pads. The pads are drilled through and that's where the parts are soldered onto the board. Notice how the pad that is further away from the flat side indicator on the silk screen in fact looks square. A square looking pad does in fact indicate where the positive lead of a part should go. With this many clues as to which way around a part should go on the board, it should be difficult to get it wrong. However, folks still manage to get it wrong. What we have found is if trainees watch our videos right through and do so more than once before they start making their robot, then there's much less of a chance of making expensive mistakes. Once you are ready, turn the printed circuit board over so you are looking at the side that does not have the white silk screen markings, and place the bright white LED long leg into the square pad hole. Guide the shorter leg into the other hole, then turn the printed circuit board over and make sure the shorter leg is coming out of the hole near the flat marking in the circle. The longer leg should be coming out of the hole in the square pad. Before you pick up the soldering iron, realize that you are only going to solder one leg of each LED. The reason why you're only going to solder one leg of each LED is because it is important these parts will sit flat on the printed circuit board when you're finished. Once you have one leg of each LED soldered onto the printed circuit board, check the LEDs are all sitting perfectly down on the board. Because you only soldered one leg of each part, if an LED is not quite sitting down properly on the printed circuit board, then you can heat up the soldered leg, and only once the solder melts, press the part down onto the board. If you press down on the LED before the solder is melted, you can cause the pad on the printed circuit board to crack and break off the printed circuit board, so you want to be very careful. Notice how I'm just touching each part very lightly on the top, so as the solder melts, it will settle down on the board. Once you are sure each LED is perfectly flat down on the board, then it is time to solder the second leg and clip off the excess lead lengths. Once you are done with the bright LED light transmitter section of the line follower module, locate the 4.7 kilo ohm resistors. They have yellow, purple, red and gold stripes, and place them on the silk screen side of the light receiver section of the line follower module that says Phototransistors. Place them inside of the outlines that are marked 4K7 and solder them in place. Now locate the phototransistors. They have a small black square chip of silicon inside the clear casing. and place them on the board from the side opposite the silk screen with the longer leg through the hole in the square pad. Make sure the shorter leg comes out through the hole that is nearest the flat side in the circular markings on the silk screen. Again, be sure to only solder one leg of each phototransistor. That way you will be able to move the part down onto the board without too much difficulty simply by heating up one leg. It is very difficult to heat up both legs simultaneously to move these parts around if they're not down flat on the board. Give it a final check, then solder the other legs if you are satisfied that everything is set up properly. To connect the line following module to the robot, you can simply solder the wires directly into the module, but it is probably better to put a connector onto the board. There are two types and both can suffice. In this video I'm going to use a single inline pin female header. So we begin by breaking off a length of 5 pins to cater for 5 volts ground, the left, right and middle sensor outputs. Again, as is good practice with all parts that have multiple pins, we hold the part in place with small blobs of solder so it does not fall right out the board while we are soldering it in. We only solder the 2 outer pins of the header strip and remove the blobs of press stick and check that it did not move before or while we were soldering it in place. If the part shifted slightly, we can heat up the solder and move the part around a little until it is in place properly. Once we are sure the part is properly located, we can solder all the other pins. Remember to clean the tip of the soldering iron on a wet cellulose sponge every time we pick it up from the soldering iron stand and before we apply the solder iron to the printed circuit board or parts. Now we have finished the 2 halves of the line following module. It is time to join them together at a 30-degree angle. Notice how the white LED transmitter board with the rounded leading edges will be sitting slightly above the square-edged phototransistor receiver board. The LEDs and phototransistors on both boards will be pointing downwards at the surface of the competition maze. Now we break some male header pin strip into lengths of 2 and insert the short end into the white LED section and solder them in place at a very slight angle. Again, it is very important we only solder one out of the 2 pins on each side. This will allow us to heat up one pin to move things around slightly where it would be difficult to heat both pins to move things around. The reason why the white LEDs are mounted slightly above the phototransistors is so that the phototransistors will only pick up the light that bounces off the maze table surface. Once the one side of the pins are secured, move the boards around relative to each other until you're seeing an angle of about 30 degrees, which will place a pool of light just under the phototransistor on the surface of the maze table. The angle here looks about right, but notice how the boards look a little bit skew relative to each other. When straightening things up, make sure the solder is melted before you apply a little pressure to the boards, or you could crack and damage the pads on the printed circuit board, which may affect the reliability of the module. Once the module is complete, locate the M3 spacers. This is what the nylon M3 spacers look like. There are 2 long and 2 short plastic spacers. Mount a short spacer on each long spacer. Find the M3 cheesehead screws that are about 8 mm long. Notice how these screws are in fact still too long. They don't screw all the way into the plastic spacer because the hole is partially blocked by the screw thread on the longer plastic spacer that joins it to the shorter plastic spacer. If you place a spring lock washer and flat washer underneath the head of the M3 screw, that will partially solve the problem. We can then fill the remaining gap between the short and long spacer and lock them together with a spring lock washer or 2 flat washers. Remember, when working with plastic parts, do not use too much force or you could damage the threads. Normally, with plastic parts, a firm grip between the thumb and forefinger will do the job, where using a screwdriver on the one side and pliers on the other side might result in excessive force and result in stripped plastic screw threads. Once you have set up the nylon spacers on the line following module, it is time to mount it to the chassis of the robot. Find another pair of 8mm long M3 screws, place spring lock washers on the shafts of the screws and tighten everything up but not too tight. With the line follow module on the robot, it is now time to wire up the electronics. You will need some single strand breadboarding wire cut long enough that it can reach from the module up to the breadboard. It is best to use single strand wire that is about 0.6 mm thick, as ordinary telephone wire is a little flimsy and has a bit of a tendency to bend when you try insert it into a breadboard or a connector header. To strip the plastic insulation off the wire, you might want to make yourself a special tool like this. We've taken 2 blades of a pencil sharpener and located them into a small plastic block with a 0.6 mm gap between the blades. Insert the wire between the blades, spin the blades around and pull, and the insulation comes off. You can also use the electronic side cutter to strip the wire, but unless you have excellent hand skills, you can nick the wire, in which case the wire may bend and break off, blocking up the holes in your breadboard. If you don't have the time or skills to make your own wire stripping tool, you can buy one like this that works properly, but they're not cheap, and that's why we make our own in the Techno Lab. The wire stripping tool made from pencil sharpener blades, spaced just slightly wider than the wire, works by cutting through only the covering insulation when one inserts the wire down the slot and spins the device around. Then, when you pull on the wire, the covering insulation layer comes off without hurting the wire inside. By comparison, one needs to use a lot more skill to get a similar result with the side cutters. To make it easier to film, we have removed the line following module from the robot to put these wires into the header. Insert a blue wire into the ground socket, a red wire into the socket marked 5 volts, green, pink and yellow wires into the left, middle and right hand sensor signal connector sockets. Now you can screw the module back onto the robot chassis. Bend the wires and feed them through the holes and insert the ends into the breadboard. Link the blue wire with another piece of blue wire to the ground header strip. Link the red wire to the 5 volts header strip. You can switch the robot on now and the bright white LEDs should light up. You can take a permanent marker pen and write L and R on the left hand and right hand sides of the line following module to prevent confusion in future. Link the yellow wire to analog 0, link the pink wire to analog 1 and link the green wire to analog 2. Analog 0 is marked A0, analog 1 is marked A1 and analog 2 is marked A2. In this shot we can see what the line following module looks like mounted on the robot, with the white LED section canted backwards at about 30 degrees. Notice how each LED makes a pool of light on the surface of the maze just under its corresponding phototransistor. Notice how bright the pool of light is when reflecting off the white surface, and how most of the light is not reflected back into the phototransistor off the black electrical insulation tape. Connect the USB cable to the robot, then test the line following module. At this stage you want to go to www.robotscience.co.za/datasheets. Select the AfrikaBOT 3 datasheets. Download datasheet 6.01 through datasheet 6.10. One way to test the line following module is to upload the program on datasheet 6.08 into the robot and open the serial monitor and look at the messages the robot is sending back to your computer. When the robot is over the black line, you should see the message middle over black. When you move the robot to the left, you should see the message right sensor over black. When you move the robot to the right, you should see the message left sensor over black. When the sensors are completely off the black line and they're all over the white surface of the maze, you should see the message white, white, white. When the sensors are all over the black line, you should see the message black, black, black. If things are not working perfectly like this, check and double check your wiring again. We typically do not see our own mistakes, which is why we make them in the first place, so get a friend or your instructor to take a look at the wiring of your robot. If the wiring is perfect, and when you upload the code to your robot there's no error messages, then you can also adjust the on-off threshold level of the analog inputs of your robot, which may be required according to how bright or dark the lighting in your robotics room is. The 10-bit analog to digital converter in your robot maps a range of 0 through 5 volts to a range of 0 to 1023 in 1024 steps. One can experiment with changing the threshold to 250, then try 350, then try 450, and then try 550 to see how that affects the ability of the phototransistor to see whether it is over black or white. Bear in mind the height of the sensor module above the table surface also has an influence on the performance of the line following module. One can raise the module up by removing the short nylon spacer. One can also lower the sensor by using longer screws and washers, etc. But if you put the line following module right down on the table, it usually doesn't bounce the light back nicely and doesn't work very well. If the line following module is up too high, it becomes more susceptible to interference by ambient light. Another useful way of monitoring what is happening with the line following module is to place 3 LEDs on the breadboard and upload the program in datasheet 6.07, which will switch an LED on if its corresponding phototransistor is over the white maze surface, and switch the LED indicator on the breadboard off if the corresponding phototransistor is over the black line. If everything is working as it should, then you can take a look at datasheet 6.04 and datasheet 6.05 and upload the programs which will make your robot follow a black electrical insulation tape line on a white surface. If you go to www.robotscience.co.za/AfrikaBOT, you can take a look at the instructions on how to make a low-cost practice maze for your classroom or robotics workshop using an old hollow door. We hope we will see you and your magnificent robot at our AfrikaBOT competition in October. We would like to thank you for watching this video. Please click on the red subscribe button if you would like to watch more of our exciting robotics videos.